What up, Algebra Squad? All right, now let's get to this next lesson, which is called solving systems of equations using the elimination method. So this is the elimination method. The one that we talked about before was the substitution method, and then the one before that was graphing. Okay, so what exactly are these methods for? What are systems of equations? Well, that's just multiple lines that may or may not intersect. So we understand that if two lines intersect, two or more lines intersect, but right now we'll focus with two lines. When two lines intersect, that means that we have independent, consistent system. That's called a consistent, independent system of equations. Okay, consistent, take it as we do have a solution. All right, so that first word up here means we do have a solution. Independent, take it as these two lines kind of act on their own. They got their own thing going on, right? They got their own style. You got the red line, you got the blue line. They're doing their own thing. They just happen to cross at this one point. And then once again, with consistent, we mean that we have a solution. This specific one is one solution. Now, on the same side here, you could see a little flow chart. We're staying with consistent. That means we have a solution. In this one specifically, we have essentially the same line. The numbers might look different, but it's the same exact overlapping line. What this means is our two lines are not crossing in one specific point, but every single point that creates one line is the same point that creates the other line. And we know that a line is created by infinite amount of points. That makes this infinite amount of solutions. That's why we're on the consistent side, because we do have solutions. Now, what do we call this? Well, we call this dependent. Think about it as one of the lines being dependent on the other because, you know, they both share the same thing. The answers for one line are the same answers for the other. All right. They're not independent and they don't got their own style. All right. So next we have the negation of consistent by the prefix in. Inconsistent, we'll say that we have no solution. All right. In means not. So we have no solution because there is no shared coordinate. There's no intersection. They don't have, these two lines don't have a point in common. The blue one, don't mistake, the blue one has infinite amount of points, just like any line ever. And the red one has infinite amount of points as well. That makes this line, but they don't share it. If they don't share, if they don't have a point in common, then we say that the systems of equation is inconsistent because it has no solution and the lines are parallel. That's it. That's all there is to it. So like I said before, in the previous two lessons, we've learned how to graph them and find these three different types of, I don't want to say solutions because one of them doesn't have solutions, but outcomes. These three different types of outcomes. The first one was graphing. Very simple. All right. Now let's go to this slide right here because it paints a better picture of what it is that I'm talking about. Three methods in total. The first one we talked about was graphing. Now, a little memory lane. Both equations must be written as y equals mx plus b, and then we graph both lines and see where they meet, right? Does that paint a picture? Does you know, a little reminder there? So, right. The reason why we want to see them both in slope-intercept form, meaning solving for y, or y equals, or the y is by itself on one side, is so we can graph it easily. We could see where the y-intercept is, which is the number 3 in this case, and then we can see the other y-intercept here as -2, and then we can see the slope of this line, which is 4, and the slope of this line is -1. Okay, so it's in graphable format, if you want to call it that. All right, so we learn how to graph it and find the point that they have in common, and in this case is -1, -1. Next, the second method we talked about was substitution. Substitution is where we have, once again, we have two equations of two different lines, or maybe essentially the same line if they overlap, but we have two equations, and that means we have four variables that we can think about of isolating. We have an x and a y from one equation, and then the x and the y from the other equation. All we got to do is pick one of those, just one of them, doesn't matter which one, isolate it, and then go through the substitution process. All right, so as an example, I'm going to be using the same two equations as the one here on the left-hand side. So what do? Well, I could see that, whoa, here we go. I could see that both of these are solved for y. So it doesn't matter which one I grab. It doesn't really matter which one I grab. So I'm going to go ahead and grab this because that says that is what y equals to, right? Y is equal to this thing right here. So what I'm going to do is I will utilize it, Come on, smartboard. Stop being not so smart. I will utilize it and I will place it here, replace it, substitute it for that piece right there. And this is what it looks like. Okay. Oh, my Lanta, the world is against me. So go ahead and see and make sure you understand what you're looking at. All right. Now, oh my God, Mr. C, it's backwards. You wrote the 4x plus 3 on the other side. It's okay. It doesn't matter. We're just still saying that both sides are equal to each other. From here, we go ahead and see that we can isolate or solve for x by, I can take that negative x to the other side. My gosh. Let's do this here. All right. So I can take this negative x right here to the other side by addition because it's the opposite. And now we'll have 5x's here. Then I can take this 3 to the other side by subtraction. And we know that a -3 and a -2 makes -5. Okay. I don't know what's going on, but the board doesn't want to cooperate. And then lastly, we can take 5 to the other side by the, oh, I think I know what's going on. I know exactly what's going on. Let me take this away. This is pushing the screen down. That's what it is. Yeah, I'm just going to show everything at once. That's what's happening. So I know that my x value is -1, right? By taking this 5 and dividing it to the other side, I get -1 here. And then once again, I do the substitution method because I now know what x is. I can grab this, which is known, and plug it into any of my original equations. I can plug it up here, 4 times -1, or I can plug it right here at negative and then -1. So essentially, this will become a +1 minus 2. It'll turn into a -1 again. So I decided to plug it into that first one, and this is what it looks like. All right, we've done this. And if you have brain fart, go watch the other video. All right, so here we go. Third, and the reason why we're making this video, line them up. All right, line them up. Look for matching coefficients. This is going to make a lot more sense once we get started. So don't worry about it right now and just wait for the practice problems or example problems. Look for matching coefficients, add and subtract to eliminate, right? So you think there's something important here? Let's see. Boom, made you look, ha, sucker. Obviously, you got to wait. I'm not going to give you all the steps here. So what better than an example problem together? Here we go. Use elimination to solve the system of equations. So what is this method you speak of, Carreño? You have not taught anything at all. You just said we know 2 methods and we're about to learn 1. Exactly. Here we go. So what we want to do here, the trick is we want to add or subtract these equations. So in hopes that one of our variables will eliminate, right? So cancel out. Now, how do 2 numbers cancel out? 2 numbers cancel out if they are opposites from each other and you add them. For example, if 5 and -5 are opposite numbers, if I decide to add these 2 numbers, a 5 plus a -5, or you can just essentially say 5 minus 5, it'll be 0. That's called elimination. Very simple. Now, what would I do if I have 2 positive 5s, right? That's a +5 and that's a +5. How do I cancel these numbers? Once again, you have 2 options. You have the option of addition and you have the option of subtraction. So I will choose to subtract these 2 numbers, once again, eliminating them. That's it. It's as simple as that. So I am going to go ahead and tell you exactly what I would do with this and explain my reasoning behind it. Now, the first thing I want to do is make sure that my variables are lined up. Are these my x's? Yes, they are. Are these my y's? Yes, they are. Are these my constants? Yes, they are. Everything's lined up, so I'm ready for step number 2. Step number 2 is looking for coefficients that match, meaning the same number. That's a 3 and that's a 5, not the same number. That's a 5 and that's a 5. That's exactly what I want. Exactly what I want. I'm going to go ahead and create a line right here. And I'm going to ask myself, I have a +5 and a -5. How will these 2 eliminate? Do I add them or do I subtract them? Once again, think about this very, very, very clearly. Do not say you want to subtract them, because if you have a 5 minus a -5, remember what that happens. Remember what happens when you have a 5 minus a -5. A minus negative serves or acts the same way as adding. This will give you an answer of 10. So do not think that subtracting in this case will be a good idea. Rule of thumb, if your constants have the same symbol, opposite symbols, if your constants, I don't mean saying constants, if your coefficients, the numbers in front of the variable, if your coefficients have opposite symbols, add. When they're opposites, they will cancel each other out. All right, so let's go ahead and do the math. 3 x plus 5x, beautiful. They're like terms, so I can add them. 8x. A 5 plus a negative 5, meaning 5 minus 5, cancels out. This is called the elimination process. This is the reason I'm doing this. And then 11 plus 5, that's going to give me 16. Woo! What do you think you got to do here? What do you think you got to do here? Don't forget the overall goal of this lesson. We have essentially two different lines, and we think that they're intersecting. So therefore, we're looking for that point of intersection. We want to look for that x comma y. And look at what we have here. We have, if we solve this, the variable x solved for, right? Take 8 to the other side by division. And we already know that pretty much x is going to be 2. There we have it. So we have this variable figured out. What do we do next? Well, this is kind of funny because we now have to use the substitution method. Go ahead and grab what you know and substitute it back to your original, any of your original equations. So bloop, bloop, bloop. You know that x is 2. Well, go ahead and plug that sucker back into any of your original equations, any of them. You can use the bottom one or you can use the top one. It does not matter. You can actually do both and see and notice that it actually is the same for both of them. So just for whatever reason, I'm going to choose the top one, which looks like this. 3 times blank plus 5y equals 211. And right now, here, my x is 2, because that's what I found. 3 times 2 will give me 6, plus 5y equals 11. I need to combine like terms, so I need to take this 6 to the other side with the other number that does not have a variable. This will give me 5y equals to 5, right? And then I have 4, 5, yeah. And then I'll take 5 to the other side by division. And there we have it. Okay, so check. How does that look? Oh, no, wait. I made a boo-boo. What did I just, whoa. No, I was right. My bad. I was looking at some other numbers in my head. All right. So that is pretty much the elimination process. That's it. Line them up, find what's going to cancel them out, either addition or subtraction, and then do it. Let's go ahead and see what our solution is here. Desmos, type them in exactly how you see them. 2, 1. That is going to be the intersection, 2, 1. There you have it. So we got 2, 1. Ta-da! All right. So without further ado, let's go ahead and do a little check. See if you understood. Never mind. Before we do the check, let's do another type of check. How can we, or can you think of an idea that helps us without Desmos, right? Desmos right now told us, yes, Mr. C, you did it correctly. You did not make a mistake. Here is a proof that you did it correctly. So I had a brain fart before. I thought I made a mistake, but then I was like, okay, no, I didn't. And then Desmos came to the rescue and said, you did not make a mistake. But if you don't have Desmos, what can you do to make sure you didn't make a mistake? Okay, what we can do is, well, a solution to an equation means that if you grab that x comma y, right? If you have that x comma y and you plug it, right? Because that's an x and that's a y. And you grab those and you plug them into your equation, you will get a true statement. Now, both of these equations say that that point is on that equation. So let's see if it's true. Let's go ahead and start with this one right here. What happens when we plug in a 2 for x and a 1 for y? 3 times 2 will give us 6, right? And then 5 times 1 will give us 1. Well, what do you notice is going to happen here? There it is. That means that this point is indeed, yes, it is, on this equation. I'll go ahead and circle it in green to tell you that it is on that equation. On the other side here, same idea. We go ahead and put 2 and 1 for x and y. And then we go ahead and solve 10. 5 times 1 stays at 5. And then here we have 10 minus 5, which equals 5. Woo, what do you notice? True statement once again. So how is it possible that you have two lines and one of the coordinates is true for both lines? Well, that means that these two lines intersect at that point, right? How does it make sense that you have a point that satisfies two lines. Well, the two lines intersect. They go through that same exact point together. Okay. That is how you can check. Bam. All right, here's where you do your practice problem. Pause this sucker right now and try it on your own. Go. All right. I'm hoping you did not cheat yourself. So I'm noticing right now I'm looking for, step number 1 is looking at your coefficients. You got a 5, -5, a 13, and a 3. Do you see the same numbers anywhere? Yes, I do. I see the same numbers right here, 5 and 5. Now, the next idea would be, how do I cancel those numbers? Do I add or do I subtract? Do I add or do I subtract? From the last problem, we learned that if the numbers are opposite in signs, you want to add them. Because when you're adding opposite numbers, they're going to cancel each other out. A 5 plus a -5 will eliminate, called the elimination method. And now you got 13y minus 3y. These are like terms. All right. That's going to give you 10y. So you can subtract them. And then 20 plus 30, that's going to give us 50. What do I do here? Well, I could see that I'm on target. I'm on track to finding what my y value is by division property of equality here. I now know that my two lines will intersect at the point x comma 5. I don't know what the x is yet, but I know what the y value is. All right, so now that I know y, time to plug that in back to any of my two equations up top. Once again, any of your two equations up top, it doesn't matter. You choose whatever you want. Now you got two options. You got the, whoa. You got the top equation here, which deals with positive numbers, and you got the bottom here, which deals with smaller values, but negative values, negative numbers. So just for whatever reason, last one I chose the bottom. So this one I'm going to choose, last one I chose the top. So this one I'm going to choose the bottom. Silly me. I don't know x. I do know y. So I'm going to plug in y there. Remember, the parentheses is going to be a space for the number that you already know, right? So you could see now from my equation, the only thing I still don't know is the x. All right, so we got -5x minus 3 times 5 is 15 equals 30. What do we do here? Well, we want to get x by itself. So I begin by taking the 15 to the other side, addition property of equality, cancel. That's going to give me -5x equals 30 plus 15. That's going to give me 45. And then lastly, we'll take this -5 to the other side. I know that they're multiplying. The opposite of multiplication is to divide. And I do bring the negative with me. Don't forget about bringing your negative with you. If not, then that x stays negative. And I don't want to find negative x. I want to find x, positive x. What do we get here? We get -9. Okay. 45 divided by -5, -9. So it appears that our answer would be the lines that are given to us, the two equations, they intersect at the point -9, 5. Neat. All right. Now we do know that we are able to graph this x and y. We are able to grab the x and y and plug it in here into these two. And if it's true for both, that means I did my work correctly. And that is the line that, I'm sorry, the point that where these two lines meet. So you got the red line, the blue line, -9, 5. Here's Desmos coming to the rescue. All right. Good stuff. All right. Example número 2. Write and solve a system of equations using addition. So same idea, but now we got words. All right. Here we go. 7 times a number, x, minus 4 times another number, y, is 13. So let's go ahead and start writing that one out. This one, I'll go ahead and do it in blue. So here, right here, and right here. So 7 times the number x. So 7 times x is just 7x. Minus 4 times another number, minus 4 times another number, y. So 4 times y is 4y, is 13, is 13. There I have it. Okay, here we go in red. -7 times the number x. So -7 times x is -7x. Plus 7. So plus 7 times another number, y. Okay, 7 times y is 7y. Yeah, I don't know why. See my two different y's? I don't know why my y's are looking like that. You know why? I don't know why. Is 14. Is 14. Okie dokie. We got our two linear equations in front of us, and now we need to see if they intersect, and if they do, where. So I challenge you, stop right now and try it on your own. Okay. Okie dokie artichoke, here we go, guys. So everything's already lined up. I got my x variables lined up, my y variables lined up, and my constants lined up. Perfect. The next thing I want to look for is coefficients that are the same number. 7 and 7, here they are. Now, right now, I don't really ask myself, or when I was looking for the same number, I wasn't really looking for identical numbers. I could see that this 7 is positive while this one is negative. I don't mind that yet. Now, in this next following step that I'm going to talk about is when I think about that positive or negative. So I know that my x terms are both 7, right? The actual numerical value. And then I also see that, one is positive and one is negative. That is what guides me to tell myself whether I'm adding or subtracting my equations. And in this case, once again, we are adding because they're opposites. A positive 7 plus a negative 7 eliminate. And here we have -4 plus 7. 7 is larger, so we're going to stay at the positives. It's the same thing as saying 7 minus 4, which gives me 3. And then here we have 13 plus 14. That is going to give us 27. Okay, so what do we do from here? We isolate the variable by taking 3 to the other side, division property of equality. And now we have y equals 27 divided by 3, or what times 3 gives me 27, and that's going to be 9. Okay. I can see that these lines do intersect, and the y value of that intersection is going to be 9. The next thing I want to do is grab any of my originals, and plug in this number 9. Okay. I see that this top one, I don't know why, but this top one has a -4 instead of a -7. I prefer dealing with even numbers that are negative instead of odd numbers that are negative. So I don't know. That's just my brain. So here we go. We got 7x. I don't know what x is, so I'm leaving it as x, minus 4 blank. I do know that, so I'm going to put it in right now. So I know that y is 9. So we have 7x minus 9 times 4 is 36 equals to 13. All right. If you did not get this far on your own, pause it. Try to pause it as much as possible in any single step, so you can try to do it on your own as much as possible. Okay. All right. Let me stay with green. In this step, we will take 36 to the other side, because we first have to get rid of the addition and subtraction numbers. We're undoing PEMDAS in this section. Here we have 49. And then lastly, we need to take 7. I know that 7 is multiplying with x. I'll take it by division. That's the opposite of multiplication. Cancels out. And remember that canceling out in this piece right here means that it turns into a 1. A lot of students keep thinking that canceling out turns into a 0. Do not think that. Do not think that. Don't think that, because then you're telling your subconscious that every time you see a number divided by itself is going to be 0. And y'all are making these mistakes in your quizzes, and I'm seeing it. Be careful. 49 divided by 7 is 7 once again. Okay, so it appears that these two equations of lines, or the intersection of our lines, are going to be intersecting in this point right here. So we have two options for checking our work. One of them, which we have readily available at any time without technology, which is we can grab our y of 9 and x of 7 and plug them into the blue one and the red one, and make sure that it is a true statement, that the blue one does actually turn into 13 and then the red one actually turns into 14. Now, because we were making this video, we need to expedite the process. So let's see what we get here. We got 7x minus 4y equals 13. I did something wrong here. And then we got -7 x plus 7 y equals 14. We can see in this little corner right here that we have the intersection at 7,9. Is that what we got? 7,9. Yes, we did. Cool beans. Cool beans. Hopefully you're understanding this. If not, you are pausing it, rewinding it, and asking me questions. All right, try this one on your own. You got this. Let's do it. 2 times the number x, that's 2x. -6 times another number, which is y. So -6y is -6. Here we go. The next one starts with a -2 times x. So that's going to be -2x. Plus 5. Okay, plus 5 times another number, and I'm guessing it's y. Duh. Is 18. All right. I'm going to stop right here for a few seconds. If this is not what you got, please, please, please make sure you pause it right now and try it. Try it without me. All right. Okay. So we got our I'm sorry, not coefficients, our terms. Our terms are lined up. You got your x's, your y's, and constants, right? First thing is most important thing. The next thing is looking for the numbers or the coefficients that are the same number. We got a 2 and a 2 for the x's. Perfect. That's going to be our aim. That's going to be our goal. Now, not always are these two going to be the matching ones. So don't worry about that. Sometimes these could be the matching ones, right? So not only the first ones are going to be the matching ones at every time. All right. So don't think of that. We do see that positive and -2 are opposites. So by adding them, they will cancel out. So by me adding these two equations, that's going to eliminate, hence the elimination process method. And now make sure you don't mess up with your signs. You have a -6 plus 5, a -6 plus 5. That's the same thing as saying you have a +5. Look, you have a +5 and you have a -6. You can rearrange this so your brain understands it, right? This is still a +5. That's still a -6. If you want to rearrange it this way and ask yourself, what is 5 minus 6? Tell yourself this, by all means, do that. It's going to give us -1, -1y. Next, what do we have? We have -6 and a +18. That's the same thing as a +18 and a -6. What does that give you? It's going to give us 12 right here. Cool. So, the last piece here, remember, we still haven't gotten y isolated. We still want to get this -1 to the other side, understanding that that's multiplying. Therefore, inverse operation would be to divide. Don't forget your negative, homies. Homies. That's going to be y equals, and we just switch the sign here, -12. Pew, pew, pew. Pew, pew, pew. All right. So, what do we do now? We already did the elimination process, and now we actually do a little substitution. Substitution by grabbing what we know, y is -12, plugging it into whichever original equation we have here. So, I don't know. Let's see which one I want to do. Let's do the top one now. So I started with the top one, then I did the bottom one. Now I'm going to do the top one again. So I don't know x, so I'm going to stay at 2x. I do know y, which is -12. And then, where am I? Okay, here we go. And then, where am I? -12 equals -6. All right, that's where I'm at. So first things first, we want to multiply this. Nothing happens with our 2x. 6 times 12. 6 times 12 gives us 72. A negative times a negative. They're both negative values. Makes a positive. So this right here will give me a positive 72. All right. And now I get equals here, -6. Right. So from here, we need to take 72 to the other side. But 72 needs to be taken by subtraction, which is going to make more. Where's my red marker? Here it is. So 72 here. Boom, boom, boom. And once again, this is what trips up a lot of the students, having this war with the signs of numbers. integers. We got -6 and -72. They are from the same exact team of positive and negative, right? We got more negatives. So 72 and negative and 6 negative makes a total of 78 negatives, right? Now, when we take 2 to the other side, right over here, take 2 by division property of equality, we get half of 78. More specifically, -78. Half of 78 would be 39, -39. So this seems to be our answer. Our answer is these two lines intersect at the point -39, comma, -12. And I'm going to say it one more time. As long as we have a problem, I'm going to keep repeating it. The way that you know that this is true, if you're taking a test and you have enough time, you can grab this X and this Y and plug it in for X and Y. It needs to give you -6. You plug it in for this X and Y, and it needs to give you 18. If it does that, that means you found the right solution. All right. Once again, let me pull up Desmos really quick, just to be safe and making sure that we did the right thing here. 2x minus 6y equals -6. And then here we got -2x plus 5y equals 18. Okay, so it seems like these lines are not going to intercept, but they do. They have very slight, there we go. I was going to say very slight difference in slope. -39, comma, -12. Cool, dude. All right, done with that one. Hopefully you guys got it correct. If not, this is a video. Play it again. Okay, okie dokie. Now, example número 3. Example número 3 says eliminating using subtraction. So keep in mind that this is going to have a little bit of a difference to it. How much? Not that much. Very simple. So what I want you to do is I want you to stop it right now and try to see where your brain takes you with this one. Try to see where your brain takes you with this one. Okay, so same thing, same idea. You want to make sure that your terms are aligned. You got your X on top of your X, your Y on top of your Y, and then 30 on top of 6, which are numbers without variables. Perfect. What I want to do now is I want to ask myself, are there any of these that have the same number? And yes, there are, 6 and 6. Cool. So that means I can now move into either adding or subtracting my equations. Whoop, there's a little hint right there. So the only way that we can get rid of a 6 and a 6, a +6 and a +6, is by subtraction. Only way that we can do that is by subtraction. So be careful with that. Not by addition. If you add them, you're going to get +12y. So what happens if we add these two, subtract these two equations? You got to do it in order. Okay, so you have to do 3 minus 5 because the 3 is on top. You can't mix match the order and do the order that you want. So 3 minus 5 is going to give us -2x in your x's. And then here we have a 6y minus a 6y is going to cancel. Once again, this is called the elimination process because of that. And then we have 30 minus 6, which is going to give us 24. Cool. All right, then you already know what to do in this final step. You take -2 to the other side by the division property of equality, and that is going to give us -12. Look how simple that was to get our first I'm losing my word right now. The y value of our coordinate. Yeah. All right, so nothing new here. Now that we know our x value, we will go back to our originals here and choose any of these original equations so we can insert that -12. Let's see. Let's go with the top for whatever reason. Okay, so once again, the reason why I put parentheses around x is because I already know x. X is -12. So I can put -12 right here and solve to find out y. All right, so the reason why I chose this one is because I know that 3 times 11 is 33, but 33 plus 3 more is 36. So that's going to give me a -36 right here. We're adding 6y equals 30. How do I take 36 to the other side? Well, the only way, Mr. Carreño, is by adding, because a negative and a positive cancel out. Plus 36. So what do we get here? We are now going to have 6y is equal to 66. What do we do here? We take this 6 to the other side by division. Ooh, I better finish this problem fast because it's looking sketchy with these 6's. The number that's going to give me 66 would be 11 by multiplying, or 66 divided by 6 gives me 11. All right. So my final answer, let's go ahead and write it nice and neat to tell the crowd where these two lines intersect. The x value of -12 and the y value of 11. Bam! Circle that sucker and call it a day. All right, let's do a quick check on what we did. Remember that decimals is always going to be your best friend for a quick check in your work. 3x plus 6y equals 30. And we have here 5x plus 6y equals 6. Open this sucker up, back it up, zoom out, find the point of intersection, -12, 11. -12, 11. There it is. All right. We are done with this one. Now, go ahead and try this check problem. And I'll give you the solution in a little bit. Don't cheat yourself. All right. So, drum roll, please. The answer to this system is -3, 14. This is where these two lines will intersect. Remember that if you did not get this, you need to go and check your work. Make sure that you actually added or subtracted the correct way and dealt with your positive and negative numbers the correct way. All right. If you are not able to get this answer, reach out to me. If not, peace out and get ready for the next video. See ya.